and all the tools that Webrecorder creates are fully open source. Everything is open source and available on our GitHub. And another key goal is to integrate with existing archival systems. So not necessarily create another archive, but to empower users to put web archives into archives that already exist, including institutional repositories, other types of archives, extend existing web archives, and so forth. And so today I wanted to focus on kind of 4 key tools that we'll be working on over the next year. There's definitely a lot more, but these are kind of the key tools that are currently the focus. And these tools are, and so I'll go over each one briefly, and then definitely can answer more questions. So basically the first tool that I wanted to cover is Replayweb.page, and it is a fully browser-based archive replay system. And the idea is that it renders work files and WACZ files directly in the browser, so there's no additional server running. It can be embedded into any other web page, and it can load web archives from a variety of online sources, from HTTP, from S3, Google Drive, and even IPFS. And it has built-in page URL and text search, and it also supports lists and sort of a story view from the previous Conifer Webrecorder desktop tools. And so the idea is to essentially have a kind of a fully JavaScript browser-based system that can be run anywhere inside of any other web page. And so currently on our roadmap is improved documentation and a user guide for Replayweb.page, making it even easier to embed, and also to add Flash support via the Ruffle emulator. Flash support, of course, as many of you know, is no longer possible. Flash is no longer supported officially in browsers as of now. You could still run it, but not easily. And so with the Ruffle emulator, we'll try to make that a little bit easier. And a key goal of the system is essentially to make it as easy to load web archives as it is to load videos and PDFs directly in the browser. So if you could load a video or a PDF and put it inside a website, you should be able to do the same with a web archive. And also would like to support integration with additional data sources and with institutional repositories, and to be able to essentially integrate Replayweb.page into systems such as, for example, Islandora or Archivematica, and so forth. And we actually have a prototype integration with Archipelago, which is a new repository system that's being developed at Metro NYC. So that's Replayweb.page. Next tool that actually just announced yesterday is the Archiveweb.page browser extension. And Archiveweb.page extends and complements the Replayweb.page system and adds the capture capability and sort of the full recording mode that Webrecorder is known for. All of that functionality is now in Archiveweb.page. And basically it's interactive browser-based archiving. So anything that's loaded in the browser with the extension enabled will be archived. It has built-in full-text search support. So as you're browsing pages, it will capture the text. It also has export to work into the WACZ format, which we'll talk about in a bit. And it has even some experimental peer-to-peer sharing using IPFS. So you could actually archive something in your browser and then send a link to a colleague, and they can load it directly where it will connect to your browser and download that archive. That's a little bit experimental, so it's still in development, but it is there. And then also it has Flash archiving via the Ruffle emulator. So that's also in this initial release. On the roadmap for Archiveweb.page is a desktop app And so this desktop app will actually replace the current uh, Webrecorder desktop app, and also adding the autopilot system that was in Webrecorder desktop and Conifer. That's not yet in the extension, but it's definitely on the roadmap and will be added in the near future. And so the idea with this is that uh, essentially the Archiveweb.page system, both the extension and the desktop app, will replace the current Webrecorder desktop system. They're both based on the same code base. They should run. They should be a bit more robust, actually, since it's a fully JavaScript-based implementation, whereas the current Webrecorder desktop app has a mixture of different tools. It uses Python and Redis and JavaScript, and so we've had some. I know that there have been some reports of it not working on the latest Windows and Mac, and so the new Archiveweb.page app will replace that and will work much better. And the extension is already available, so you could install it in your browser today. And essentially, it will archive exactly what's being loaded. And I'll do a brief demo of it later. Oh yeah, with the new app, we'll also have a migration path for those that are using Webrecorder desktop today to migrate to the new Archiveweb.page app. The next tool that we're focusing on is pywb, which is sort of the perhaps the oldest Webrecorder tool. It is that pywb stands for Python way back. It was initially created about 6 years ago and was kind of the core system that powered Conifer and Webrecorder desktop. pywb has both a replay mode and a capture mode, and can also act as a proxy for both capture and replay. Has extensible configuration options. Recently, we've added localization support and an access control system, and working with the IPC community, recently released a migration guide from OpenWayback to pywb. And so the idea is to essentially kind of act as a full-fledged Wayback machine that can be deployed on a server and support a variety of archival sources for large-scale web archives. On the roadmap for pywb is there's a 2.5 release, which has been very close, but should be coming very soon. And then after that, there will be support for deduplication and a patching mode for capture. So currently, the core pywb does not support patching yet, and so that's planned to be released in the near future. Then also support for the WACZ format, and later on a more component-based setup and interoperability with the Replayweb.page replay. Ideally, we'll have a way so that pywb can use the same replay system as Replayweb.page, but also switch back to a server-based replay if for older browsers and for situations where that's not possible, and kind of have better alignment of those of all these replay approaches. And then also to support the IPC community, there's a project to add improved access control, such as embargoes, localization, and additional UI improvements, such as, for example, perhaps might have a header with and essentially match the UI that is available in OpenWayback, for example, and kind of other improved calendar view and so forth. And so that's kind of on a little bit of a longer term for the next 6 months for pywb. And so that is pywb. And then finally, the next big tool that I want to cover is Browsertrix. And there's actually so Browsertrix is the automated high fidelity crawling system from Webrecorder, and there's actually a current iteration, which is Browsertrix, and then there's a very new browser system called Browsertrix Crawler, which we've been working on, and actually haven't yet fully a blog post is coming on the system in the near future, but this is basically kind of a refactoring of Browsertrix to into an even smaller component, essentially an all-in-one Docker container that can run a crawl. And so the idea is to kind of simplify Browsertrix a bit so that you could essentially start a Docker container on a command line, and it will run a single crawl. And basically you start a command, and when it's done, at the end of that, you'll have some work files and a WACZ file. And currently it supports a variety of command line options, and it's basically using Puppeteer. And so the idea is to make it extendable via essentially a Puppeteer script, which is a browser automation system that was created by Google, and it's an open source project, and it actually works pretty well for crawling automation. And so the idea is to make it very extensible so that you could create a custom crawl driver. The default one just visits all the links that are on a page in scope, but a custom crawl driver could do additional things. Yeah, so this is still in development. We'll have more updates on this in a blog post. On the roadmap for it is, of course, WACZ support, additional crawling options, support for URL lists, and support for browser profiles. So you could start with not just an empty browser profile, but one that's already logged into social media, for example, and start crawling from there. And also support for the behavior and autopilot system that will be used in Archiveweb.page. The idea is to essentially have the same system that can work in both the browser extension and in Browsertrix. And that will require a bit of refactoring, but the idea is to kind of have this shared automation system for behaviors as well as for crawling. So Browsertrix crawler itself is just a crawling system. It doesn't do any for basically on a single site or a set of URLs, and then separately from that will be a separate scheduling component, which could be as simple as just running on cron job, or it could be as complicated as setting up Kubernetes or Docker Swarm. And so that's kind of a little bit further out, but that's basically the idea. And these are essentially the four key tools that Webrecorder will be focusing this year. Of course, to support these tools, there's lots of other small packages within the Webrecorder ecosystem, but most of the work will be oriented around this. And one of the things that all these tools that I've mentioned will be supporting is the new WACZ format, which is a new format called that Webrecorder is developing. And I'll actually turn it over to Emma to talk more about the WACZ format.
Can everybody see the slides? I was just going to go through this kind of quickly because I know we don't have that much time. Yeah, so the WACZ format, the really short pitch for it is that it's a really convenient zipper for work files that includes a bunch of metadata that allow you to basically self-host a full web archive with full text search. That's like the really high overview. So currently the state of the data formats used in web archiving, I think this isn't super new to anybody here. There are two main formats, basically the work and a CDX or CDXJ, which is a plain text index for work sorted by URL, timestamp, followed by a JSON line. And there's no agreed upon format for page, full text search, or other metadata. So that's part of what we were trying to address with the WACZ format. Most web archives traditionally have a portability issue. They're really big. The access to some of the data is provided by the Wayback Machine or other tools, and there's custom policies around metadata for depending on sort of where you're working, what you're working with. So what we've tried to focus on is making that whole process a lot simpler. Basically, we want to focus on smaller web archives, millibytes and gigabytes that can be exchanged as data. We believe the web archiving data should be fully portable, You should be able to share not just the raw work file, but also additional metadata and other data needed to access the web archive. We have a custom metadata file that follows the frictionless data format. I'll get into that a little bit later, but we're basically trying to standardize the way that you handle metadata for these types of archives. So like I said before, WACZ is a web archive collection zipped. So it contains multiple types of web archiving data files. The data package.json file, which as I mentioned is basically the part of the frictionless sort of data standard. And the files are all packaged together in a standard zip for portability. So you can unzip them like you would any other zip file. And I'm going to go into, after this slide, I'm going to go into what files we include in the WACZ file, so you have an idea of what it would look like if you unzipped one of them. But really quickly, the sort of social pitch for WACZ is that a web archive collection should have a random access index of all the raw data, preferably with minimal seek, a set of pages and entry point URLs from which the user can browse a web archive, and other user-defined editable metadata about the web archive collection. You know, a title, a description when you scraped it, and basically you need all of these things to have a really solid web archive that's easily usable. And so our goal is to provide all of that in a single file format so that you can just spin one of these up really quickly and have a user looking through, you know, this sort of self-determined web archive. As a bonus, it supports fast random access. Because it's a zip file, it's really easy and efficient to load small amounts of data. Again, we're focusing on sort of gigabyte size here, nothing too crazy, no terabytes. But you can access this remotely without downloading the entire file. And this is possible basically because of the random access properties of standard zip files, in addition to us bundling the index with the raw data. So what is, you know, if you unzipped a WACZ file, what would it look like? What's the point of this? A WACZ file basically contains the following. There's an archive folder, there's an indexes folder, there's a pages folder, and there's a data package.json file. And so I'm just going to go briefly into what purpose all of those things serve. So the archive folder contains a copy of the work that you have used to create the WACZ. You could put other things in there, but that's if you use the basic command line tool, that's what you're going to get either in a work format or work.jz format. So you're not losing any data by zipping everything up in a WACZ file. You're going to still have the original work. If you unzip everything, you can just go to the archives folder and the original work is right there. And then the indexes folder should include various indexes into the raw data stored in the archive folder. So currently right now we support CDX, .cdx or .cdxj, as well as compressed CDX, a .cdx, .jz, and an IDX indexes. And you can pick which one, which index format you would like from the command line when you're creating your WACZ file. But there's always going to be an indexes folder with an index of your data. And then there's also the pages folder. And this is like one of my favorite parts of this, because the pages folder will always contain a pages.jsonl file, which is a list of the pages in your archive, each line containing at least the following fields: the URL of the page, the timestamp, the title, the ID, and the text. So if you enable the optional full text extraction of the page, you're going to end up with a pages.jsonl file that is basically the entire searchable text content of your work, which is super useful. If you've ever tried to set up search on a web archive that you're hosting, you know how difficult that can be. So this is a really convenient file for that purpose, because it basically just contains all of the text along with the index. So I kind of just gave the pitch for that because the text extract flag is optional. If you don't enable it, you're going to just get a pages.jsonl file with the really simple metadata that I mentioned. But like I said, there's a lot of benefits to having the full text extract. So it's an optional flag that you can pass at creation. And then the data package.json file. So we have been using the frictionless sort of data format. So we adhere to that. You can validate our data package with the frictionless, either the web UI tool or the, they also have packages in Python and that sort of thing. And it serves as a manifest for the web archive. Our current implementation is pretty simple. We use either SHA-256 or MD5 on the resources, which are the files that are included in the WACZ, and we record metadata that the user can pass to the create command. So if you were to use the WACZ create command on the command line right now, you could specify the title, description, the main page URL, which would be sort of the entrance point, and the main page timestamp. And those would appear in your data package.json file. This is just a little bit about sort of what we use frictionless for. We use their library to validate our data package file so that we stay compliant with the community standards. And we also manually check that our resources have accurate hashes and refer to pages that actually exist. So one of the other things that's, this is kind of mentioned really briefly, but you get a hash for all of the objects in the file in this data package. So if you want to integrate it with some sort of fixity system, or you just want to make sure that things have stayed free of data rot, you can use the data package.json file to check the hashes. And tools for working with WACZ. Right now, you can use our command line tool, which would be pywb, and you can use it as a command line tool. You can validate, sorry, my wife just got done with her teaching her first class of the semester and she's very excited. So you can create WACZ files from works, and you can validate existing WACZ files. Our package comes with the create function and then also the validate function so that you can ensure that you've created something that actually adheres to the standards. Some of this goes into what Ilya already said. Replayweb.page supports WACZ. We don't really have to go over this again because I think it was kind of already gone over. So we can go straight to, I guess, the next section. This is just, if you have questions or recommendations, you can contact us or you can post in our forum. That's always encouraged.
Yeah, thanks, Emma. And we'll take some questions at the end, and I'll just do a very quick demo of the recently released Archiveweb.page extension, and just kind of tie a bunch of things together and kind of show how the WACZ format can be created and used. And so I'll turn on my screen again. And so Archiveweb.page is so again, it's a browser extension, also will be a desktop app in the future. From the Archiveweb.page site, you can install the extension if it's not already installed. If it is, you'll see a link to browse the archives that are in your browser. And so all the data that is archived with this is actually stored in your browser in a kind of as part of your browser profile. So if you create a new profile, it'll have a separate set of archives. And so if I click on that, these are kind of some of the archives that I've created. Most of them are tests. And I just kind of wanted to highlight some of the things that it can do very quickly. And so, for example, if I go to, let's say, the Webrecorder.net site and have enabled the extension here already, and then from here, I can either create a new web archive. For example, I'll call it demo. And so this creates a new web archive collection, and then I can simply click start, and this will turn on the Chrome debugging mode, which is sort of required because it's essentially using the Chrome debug APIs in order to be able to capture things at full fidelity. And so it'll show this bar here, and sort of, if you're familiar with Conifer and the Webrecorder desktop, this is sort of a similar approach in that what is being archived is exactly what you browse. So as I click on new things here, this size counter goes up. I can click on this to kind of see where things are at. So so this isn't terribly interesting. So maybe we'll try a different site. So here is, for example, a Facebook videos page, and this is I can also click start on this, and as it's loading, you can see the size kind of going up. Hopefully it'll work since this may be a large video that's loading here, and you can kind of see the size counter going up. And so I'm already logged into Facebook, so it's not capturing any login information since the browser is already logged in here. And this status indicator here shows if it's currently loading additional URLs or if it's idle. And so if it's idle, that means that I can continue navigating. So probably if I scroll down, let's see here. So this video, it's not too bad. Maybe if I click on, so this is a 43-minute video, maybe I'll click on a smaller video here, and you can see the size counter. So this shows how many URLs are currently in the process of being recorded. And so it is, oh, maybe I'll stop that now. And so ideally it should have recorded that video. And here we see that it's got quite a lot of URLs here. So hopefully eventually it will, so again, Facebook is hard. And so now actually, I think I went to my Facebook homepage, so maybe I'll stop recording Facebook for now and show something else. So here is a Flash site. This was added just recently, support for Flash using the Ruffle emulator. I don't have Flash enabled right now, but if I start recording, I should be able to capture this Flash site because Archiveweb.page extension adds the Ruffle emulator. And so it may not work perfectly yet, since this is, Ruffle is basically an emulation of Flash that's being developed separately as a full re-implementation of the Flash runtime. So it does work pretty well for older Flash sites like this one, for example. And so, and I can see how this is actually being loaded in Ruffle. And I think this particular Flash project loads many files, so I would have to probably go through all of it to ensure that it's fully captured. And of course, another test that I can do is just archiving Twitter. Always a good test for high fidelity archiving. And so as I browse around here, so ideally what I'm loading here is being archived. And if I probably click on another link, like for example, GitHub, in this case, it opened a new tab, and this tab is also being archived now. And so I will go ahead and stop. So I can actually just click cancel. That will stop. I can also, from the extension drop down, I can then either view this page or I can browse the entire. So I'll just click on view recorded page, and now I'm in the replay for this this page, and then I can also actually see everything that I've just recorded here and their approximate sizes. And so from here we can see that the Facebook videos ended up archiving around 160 megabytes, whereas some of the other sites are much smaller. So let's see if and I can also do full text search here. So, oh, maybe not. Let's see here. Okay, so you can see that there's some text that's been extracted from Facebook. If I search for other sites like MoMA, and it searches both the text and the URL and the title. So it will match various fields here. And so let's try the replay of the Flash page here. And so again, it's able to load that. And you can also let's try Facebook real quick and see if that worked. And again, Facebook is, I want to emphasize how hard Facebook is. I could spend all of my time just on trying to fix Facebook replay capture. And so it does look like this video, this initial video did archive. I've only clicked on one other video here. And this may or may not have worked since it appears that it has. So it can be used to archive, for example, videos on Facebook. Now, if I want to export this data, in this case, I'll just do the entire collection, and I'll download everything as a WACZ file. And so now it's just started this download, and it's basically what it's doing is it's so it's stored in the browser in the native IndexedDB database that is part of browsers now, and it's now exporting that into a WACZ file. And again, the reason this is possible is that these days browsers have evolved into fairly sophisticated applications, and there's a whole database system that exists in the browser. And it looks like the download finished, and so I can go to Replayweb.page, and I can then go to downloads and open this file, and the file loads right away. And that's because it's actually not it's not even loading the entire, it was I think around 160 megabytes, but it loads everything on demand. And so it only loads the page list initially. As Emma explained, that's kind of stored in the WACZ file. And then if I wanted to look just a single page, that loads fairly quickly because this is a small page. If I wanted to, for example, if I clicked on a Twitter, that will take a little bit longer since it's larger. And then I can also load the Facebook replay, and that will probably take a bit more since it's a larger file. And this is right now it's loading just from my local hard drive, so it's not as big of a difference. But if it's hosted remotely, then you could sort of notice the speed of loading things as it's downloading things on demand. And so this file was stored locally, and I can also, other things that I could do with it is I could put it on Google Drive. I can, and there's a Google Drive extension that allows you to load WACZ files directly from Google Drive. So that's one way to share. It could be stored on S3 or any kind of really any sort of static storage. And very briefly, I want to show what's possible is this is kind of something that was made a few months ago, but you could load a fairly large WACZ file very quickly. So this is a 17 gigabyte WACZ file that contains an archive of this interactive site that has about I think 200 Vimeo videos, but it will load very quickly, at least initially, because it's loading everything on demand. And then finally, and this is still very experimental, is this sharing feature that so it might take a while since it's a large file, but that is designed to allow you to share things on demand really directly from your extension using the IPFS protocol, which is sort of a peer-to-peer file system. And the idea is that the extension will generate a WACZ file and then put it on and share it over IPFS, and then others can download on demand through IPFS. And this feature is still a bit experimental, but this is sort of a goal of Webrecorder, is to not necessarily require you to have a centralized place for archives, but to support archives that can be hosted anywhere and make them as easy as possible to share. And so I think this might actually take a while since it's a larger file. So if this does finish, I can share a link later for you all to try. But in the interest of time, I think we'll stop here and switch to questions.